Hello. So welcome. We're Enterprise SSB, or Enterprise Save Sandra Bullock. I know, it's funny. Our idea is actually based on that movie. So what we're trying to accomplish here is to prevent astronauts to drift away out of control and provide them a way to find their way home safely by the use of wearable technology. So currently, and in fact, the target that we're trying to aim to is space tourism. Let me move on. So space tourism, it looks awesome. Like, I can't wait. It might look something like that. It might not. But the truth is that most likely, maybe in the future, maybe in 100 years from now, the space tourists might actually end up doing spacewalks. And that can actually lead to disaster. So this is a scene taken from the movie Gravity, where unfortunately Sandra Bullock drifts away into space in an uncontrollably fashion, and she cannot stop herself from spinning. Reason why is because there was nothing for her to push against. Doesn't matter what she did, doesn't matter how much she moved, she couldn't compensate for that reaction that was happening. One thing that we are taking as an assumption is that these astronauts, these tourists, will be wearing jetpacks, and those jetpacks will allow them to be able to move in space. Now, two things could happen if this event were to happen. They might land somewhere and start a new life, or most likely they're going to struggle and they're going to be really suffering. So it's super important to bring them back home safe. Now, this is the challenge that we approach. It's called Space T. Our problem is space tourism might accidentally drift away from safety while on a spacewalk. A space tourist lacks of proper training to operate the jetpack. So the solutions that we're proposing is through detection of reaction motion to operate the jetpacks and bring those tourists back home to a stable mode. After that, allow them to navigate back home or to safety through the use of hand gestures. Let's talk a little bit about the hardware that we use. The first piece of hardware is the leap motion. It actually detects hand movements, and we can actually operate commands based on those hand movements. The second one is Kiwi wearable, which has an accelerometer and a gyrometer, which means that we can actually detect the actual motion of the astronaut and predict what exactly they're trying to do, and be able to compensate the jetpack based on that reaction that the person had. So we also custom design, and actually I passed it around, and you can see Kyle wearing it. We custom design a bracket and arm to hold the leap motion, so these people will be able to literally operate it right off the suit. Let's go straight into the demo. Two things I want to show. The first one is I want to show you how the tourist, the astronaut that went and is drifting away, and Kyle is going to demonstrate right now how we can actually record the reactions. Go. Yep. So he's going bananas, right? And as you can see on the screen, we were able to record the data and get everything, the acceleration on X, Y, and Z, and the gyroscope position on X, Y, and Z as well, which means that we can actually use that data, even though the astronaut might not know, or the tourist might not know how to operate the jetpack, but it's instinctively trying to do the opposite motion of what's happening to them. Let's say they're drifting backwards. They're going to try to bring themselves forward. We can use that data to correct their positioning and bring them to a stable mode. Now, the second piece is once they are in a stable mode, we need to bring them back home safely. So they can actually operate the, go ahead, Kyle. So as you see right now, the astronaut is going forward, and through hand motion, he's being able to drive himself back very, very easily to safety. If for any reason they need to go backwards, they can actually reverse. And now they're driving backwards. And again, once they bring themselves back home, they're going to be safe. So that's about it. This is Kyle. I'm Alejandro. We're Enterprise SSB, and we're open to any questions you guys have. So leave the stuff there. So, yeah.
Okay, so I'm not going to ask a question. I'm going to make a comment again. I think that this is awesome for people who have stability problems on Earth. And so being able to measure, when people really have inner ear problems or, they're really having trouble, I could see a lot of Earth applications for that, even if it never goes to space tourism. But what you guys have put together in a short time is awesome.
Thank you. Actually, another application that someone approached us said this could actually be very useful for scuba diving. Scuba divers also lose balance very easily, or at least orientation. And this could allow them to find themselves back to balance and continue operating. So absolutely, there's many, many applications for Earth as well. All right.
Awesome.